Sentinel-2 is a multispectral imaging mission delivering high-resolution imagery with a systematic global coverage at a temporal resolution of 5 days under cloud-free conditions. Part of the Copernicus program, the twin satellites of Sentinel-2 provide continuity of spot and Landsat image data and contribute to applications such as land management, agriculture and forestry, disaster control, humanitarian relief operations, risk mapping and security concerns. Sentinel Application Platform, SNAP, is an ESA community platform created to increase the exploitation of all Sentinel missions. On top of the basic functions, like opening a product, exploring its components or navigation tools, SNAP integrates dedicated toolboxes. To enrich the capabilities of Sentinel-2 Toolbox, the Research Center for Spatial Information within the University Politico of Bucharest developed DAS Tool, a processor for Sentinel-2 Level 2A product analysis that can be installed as a plugin in Snap. DAS Tool follows the content-based exploitation plan for end product generation and entails two main functionalities, each one including several dedicated algorithms. Exploratory visual analysis, a procedure aiming to highlight predominant data features for the scene content and enable advanced data visualization that will help the user to perceive certain aspects that are not always reflected in the visible part of the spectrum, supporting data understanding. Semantic annotation, a data content representation focusing on the identification of relevant scene characteristics and further grouping based on a specific criteria by means of classification methods. This step will result in a classification map emphasizing the existing categories of objects inside the scene. Following this video, a demonstration of a regular image analysis scenario with no prior information about the scene. DAS Tool enables an upfront framework for knowledge discovery by means of an unsupervised image classification, at pixel level. Local features are extracted and grouped into pattern through statistical similarities. The idea is to automatically structure the image content and express its meaning by using data symbolic representation. For this scenario, spectral indexes will serve as features and k-means will be used for the image classification. But first, a short presentation on how to install DAS Tool. DAS Tool is a Snap-dependent application, inheriting all its functionalities to serve Sentinel-2 image content representation. Therefore, Snap and Sentinel-2 Toolbox must be already installed. To add DAS Tool, follow the Tools plugin menu and ensure the software is up to date. The version of Snap platform shall be at least 7. Select to add new plugins from the downloaded tab and upload the DAS Tool NBM application from its current location. The plugin will be installed under a general public license and the user needs to agree in order to complete the installer. At this point, DAS Tool will be listed in the Install tab and a dedicated submenu will appear under the raster main menu. However, both exploratory visual analysis and semantic annotation will become active once a product is loaded in Snap. Given the 13 spectral bands, human analysis alone is not convenient, particularly when the information recorded by the Sentinel-2 sensor is beyond the visible domain, and human ability to interpret. An RGB visualization is lacking the full perspective. Computer-based data analysis is highly required to create a relevant perception on the scene content. We start with data visualization and access MRMR function. It is available under the raster menu, the DAS Tool submenu, or by right button mouse click directly on the product. There is a dedicated graphical user interface containing a preview of the analyzed scene and one for the area of interest marked with a blue patch on top of the scene preview, control tools for the size and position of the patch, as well as the list of computed bands by MRMR to be included in the visualization. The patch depicting the area of interest can be also moved manually, by mouse click on the scene preview, or it can be automatically selected to match the area with the highest dispersion. Once all settings are in order, click OK to proceed with the computation and display the results. Once the Sentinel-2 image is available in Product Explorer, the semantic annotation function may be launched. The graphical user interface contains 3 tabs representing the main steps of the workflow involved. First one refers to the selection of input and output data for the process. The image to be analyzed will stand as the source product. From the products already opened in Snap, select the same product it was used to define the training set. The target product represents the result to be obtained. Moving to the second tab, we enter the interface dedicated to parameter setting for feature extraction. This is a step to complete from the top to bottom. At first, the user must choose the approach for the type of analysis, which is patch or pixel based. The list of available feature extraction algorithms below will update for each approach. The use case in this video presents a pixel-based analysis for which spectral indexes are computed as feature vectors. Specific parameters for each feature extraction algorithms are displayed in the bottom side of the window. Adjust accordingly after defining which bands to be considered for the computation. Finally, the last tab contains the list of features classification methods, updated according to the type of intended analysis. Each classifier comes with specific parameters that are displayed in the middle of the window after the method is enabled. The proposed unsupervised process entails for the use of k-means as a classification method. This is not a real-time process and the computation time depends on the size of the image. After launching the processing, a progress bar will appear. The result will appear as a new product in Product Explorer. It will inherit metadata from the original product, but, instead of spectral bands, this new product will include a band for each feature extracted. At the end of the list, the user will retrieve the classification mask, saved as gray-level image. For better visualization and interpretation, use the color manipulation tools from Snap and adjust the color scheme as one see fit. Finally, compare the classification result with the MRMR representation through synchronized navigation. The delineated category of objects become obvious, like water, urban or agriculture. Once all the semantic classes are identified, the user may choose colors that are more close to the natural representation. If you are curious to try it, please access the Snap web page.